So a geometric series looks like a sum of AR to the N, and the R back in your pre-calc was called the common ratio. In the calc book, he just calls R the ratio. And there's such a great theorem about this. A geometric series converges So a geometric series converges to A over 1 minus R if the absolute value of the ratio is between 0 and 1. And it diverges if the absolute value of that ratio is greater than or equal to 1. So now you don't even have to take a limit or anything. There's the little formula. All you're going to have to do is check, does my series fit this particular form? Something to the power, and the power is your counter over here. So that n is this index on your summation. Yeah.
Could it be like a n plus 1 or n squared or something like that? It just has to be
has to look like that. Very picky. But there's enough of them so that it's okay. So let's look at an example or two. And these will be nice because you'll be able to pick them up the minute you see them. So for example, suppose I said to you, does a series converge or diverge? If it diverges, no. If it converges, find the sum. If converges, find the sum. So we'll have the sum n equals 0 to infinity of 5 times 1/2 to the n. So you'd say, okay. Notice that you have a number raised to the counter, raised to the index. So the first thing you say to yourself, okay, that's geometric. Is the R value between 0 and 1?
Yes.
So the first answer is it converges. The second answer is if it converges, the formula for the sum is it's got to equal A over 1 minus R. And so 5 over 1 minus 1/2.
Which is 1/2.
So that's 5 over 1/2. And that's 10. I know, if you made 15 of those, you could all get hundreds, right? Maybe, after you've practiced so you can recognize it. Okay, so here's another one.
Converges.
It converges. And now, if this was the Peanuts comic strip, the next thing is you now conclude that all geometric series sum to 10. Yeah, fat chance. It's not true. But that would be the thing you might think from looking at this. I better give you one that doesn't sum to 10. How about this one? Diverges. Doesn't even add up. So we've just disproven Lucy's hypothesis. Now, they can be trickier. Did you notice how nice I was? I started all of these at 0. Well, you asked me earlier if I could change that exponent, and I told you no. And you really can't change the exponent. But what I can ask you to do is find the sum of this. Okay, you'd say that it converges because it fits the form, but the formula I gave you only works if it starts like that. So what we do is we sum up the one we know.
We subtract n equals 1, that is 0.
And subtract out n equals 1 and n equals 0. That's exactly what you do. Okay, so this one's going to sum to
3 over 1 minus 1/5. 3 over 4/5.
Which equals 12 over 5.
no.
15 over 4.
Sorry, 15 over
Okay, 15 over 4.
5.
You're making me doubt myself, but I think
Sorry, I thought that was
15/4.
I thought that was 3/4 over 5.
No, it's 3 over 4/5. Okay, so 15/4. So that's if I had all of them. What I say to myself is, okay, this one is missing. It's missing n equals 0 and n equals 1. So when n equals 0, I'd have 3 times 1/5 to the 0, but that's just a 3. And when n is 1, I'd have 3 times 1/5 to the first, so that's 3/5. So that answer is too big by this much. So I take that answer, 15/4, and I subtract out
3 plus 3.
the pieces that were not included in my summation. So I don't know what that is. So 15/4 minus 12/4 minus, oh, I can't do fourths. Bummer. How about an LCD of 20 maybe? So, 5 times 15, 75, 20. Somebody better be checking this arithmetic. 3 times 20 is 60. And
That would be 12.
so let's see, that's
60.
15.
12 over 20.
12 and 6. Is that right?
Guys, 15 minus 12 is 3, and 3 over 60 is 1/20.
I did 12 over 60.
Because when I wanted, oh, 12.
Yeah.
Oh, sorry. There we go. How about 20?
Yeah.
Okay, so 75 minus 60 is 15. 15
So
minus
be
12 is
3 over